Hey everyone, here's an intro to applications. I just want to go over some keywords before we start going into a couple problems. What you're going to be asked to do a lot is to write a linear model. Now a linear model could be a variety of things. It could be an equation, it could be some algebraic expressions. Most of the time it would just be one, but sometimes we'll have two. Inequalities. If in the problem you hear anything about decreasing, you know that part of your linear model, we're going to call it the rate, will be negative. And when we get to one of those, you'll understand what I mean. So just another keyword. When we're talking about some of these linear models, sometimes we'll have two, and we have to compare them. When it's equals, you'll know it's going to be one with an equation when you hear same or same price. If it's greater than or greater than or equal to, it'll be at least, more expensive, better deal. Some of these, and we'll go into it in class a little bit more about which is greater than or equal to, which is just greater than, less than, or less than or equal to is no more than, cheaper, or a worse deal. So let's just go into a couple of problems. The first one, yellow cab taxi charges $1.75 flat rate in addition to 65 cents per mile. Katie has no more than $10 to spend on a ride. So here's some key words. It's $1.75 for a flat rate, 65 cents per mile. So when you see the word per, that is the rate. So this rate goes with the variable. And let's look back to our last little slide on what no more than might stand for. No more than means less than. So when we see this no more than $10, we know it's got to be less than $10. So a few simple steps for how we solve these. First, we need to define our variables. So whatever the problem might be about is what we're going to define our variable as. Create an equation or inequality that expresses the information given, solve it, consider if our answer is reasonable, label, and check our answer. So we're going to really focus on the first three of defining our variable, create an equation or inequality, and solving our equation or inequality. So for the first one, we need to write an inequality, but we don't know what to write it about unless we define our variable. So we know that it's 65 cents per mile and $1.75 just to get in the cab. So I said that this per means rate, which means that the term after it is going to be your variable, generally. So I'm going to say m equals miles. And we're writing an inequality. So we want 0.65 m because our variable comes after our rate, right? 65 cents per mile. The flat rate is a constant. That's something that's never changing, so we're going to add 175. Just to get in the cab, it's $1.75. And 65 cents, which is like the coefficient, is how much we get charged per mile. So we go in a cab, get in the cab is $1.75. Every mile thereafter is 65 more cents on your bill. So this is all going to equal your cost, or in this case, it has to be less than or equal to your cost. So if $10 is the most we have to spend, it's got to be less than or equal to $10. So the amount that we spend on the cab has to be less than or equal to $10. It's less than or equal to because it says no more than $10, meaning we have $10, but we don't have more than that. So then we're trying to figure out how many miles she can travel, and all you would do is solve this for m. So we'd say 10 greater than or equal to 0.65 m plus 175. Subtract the 175. Subtract the 175, and you get 8.25 is greater than or equal to 0.65 m. Divide 0.65, just like we're solving any other equation, and we'll get 12.69 miles. So m is less than or equal to, notice if I pull the m over, I have to flip the sign, 12.69 miles. Now you can't round up because that would be more than your money here. So you have to be this exact or round down because you only have $10 to spend. Let's try this one. You've been given a new job in sales. You have 2 salary options. So if we say we have 2 salary options, this means we need 2 expressions. You can receive a straight salary of $500 a week. So we have one option. So no commission. Is $500. Okay? There's no change. It's $500 no matter what you do. The commission option, which would be our next option, pays you $200 per week, $200 a week plus 5% of your weekly sales. So looks like this is going to be our variable. Our weekly sales is something that's going to change. So we're going to call that S for sales. And when you deal with the percent, 5% is equal to 0.05. Remember, you take the decimal over 2 places. We're dealing with percentages. So we're going to do 200 plus 0.05s. What dollar amount of product must you sell each week in order for the commission option to be the better deal? So this option to be the better deal, we want it to be greater than the other option. So we have to have a greater than sign. And then you'd solve this like a simple 2-step equation. And that's something more than we'll do in class tomorrow. So right now we're really worried about being able to set this up. And then from here I believe all of you can solve by subtracting and then dividing. A 12-inch candle and an 18-inch candle are lit at 6 p.m. The 12-inch candle, okay, so again we have 2 things happening. We have a 12-inch and an 18-inch. So we have 2 things happening here, so we have 2 expressions. So we have the 12-inch candle and the 18-inch candle. The 12-inch candle burns at 0.5 inches every hour. So we're going to start with a 12-inch candle. And it's burning at 0.5 inches per every hour. So we're going to say H hours, right, is our variable. And we're burning at 0.5 inches. So candles start at this height. When you burn them, they get smaller and smaller and smaller. So this would be something where we're decreasing, where we'd use a minus in our expression. 0.5 H. Okay, it's not a candle that's getting bigger and bigger and bigger like your commission would. The more sales you have, the more money you would get. But in this case, the more you burn your candle, the less candle you would have. So for the 18, we are losing 2 inches every hour. So minus 2H. And then we want to figure out when they'll be the same height. So if this is the same, that means equal. Unlike the last one, which was better deal, which means greater. We want to set these equal. So we say 12 minus 0.5 H equals 18 minus 2H. And you would solve this with, putting all the numbers on this side by subtracting 12. Negative 0.5 H equals 6 minus 2H, adding 2H. So you would get 1.5 H equals 6, divide 1.5, H is 4. So after 4 hours they'd be the same, and that would be at 10 p.m. 6 plus 4 is 10 p.m. So it starts at 6, 4 hours to get to the equal point, and then it's 10 o'clock when they'll equal, which is actually what the question's asking. At what time? So a couple more examples real quick. A rectangle is 6 feet long and has a perimeter of 20.33 inches. What is the width? So perimeter equals 2L plus 2W. This is just like a literal equation where we would solve and plug in. We're going to have to deal with ones like this, so just think ahead of time about this formula. And we'll get there tomorrow. So the sum of two consecutive integers is 101. Determine the two numbers algebraically. And when we think of an integer, and we don't know that integer, we use a variable. So we'll call that x. So this is going to be integer 1. So integer 1 is x. Integer 2 is the number right after it. So how do you get from x to the number right after it? You add 1. So we say x plus 1 equals 101. Combine our like terms. Subtract 1. Divide by 2. So x equals 50, and that's our first integer. So our second integer, the one right after it obviously, if they're consecutive, would be 51. And that's how we do the seventh problem. It's actually much easier than it sounds. All you're really doing is taking a random number, picking the number right after it by saying it's that number plus 1, combining like terms, and solving for both of them. Hopefully this made some sense. Come in tomorrow with questions.